How do graph databases representing complex network data? Imagine trying to map out a social network or a transportation system. It can get messy fast, right? That's where graph databases come in to make sense of all those connections. They organize data as nodes and relationships. Nodes are like points on a map, each one representing a person, place, or thing. Relationships are the lines connecting these points, showing how they are linked. For example, a person might be connected to a city they live in or a product they bought. Both nodes and relationships can have properties, details like names, dates, or weights, that add more context. This setup is different from traditional databases, which use tables and foreign keys to connect data. In graph databases, relationships are stored directly with the data, making it easier and faster to find connections. When you want to see how two people are linked or find all the products bought by a customer, graph databases can quickly trace the paths between nodes. This makes them perfect for complex networks like social media, fraud detection, or recommendation engines. The nodes can be labeled to show what kind of entity they are, like user, product, or location. Relationships are often directional, meaning they go from one node to another, and they can have labels like friends with or purchased. These labels help clarify what kind of connection exists. Both nodes and relationships can have properties, such as timestamps or weights, to give more details about each connection or entity. Because relationships are stored explicitly, graph databases excel at traversing paths across many nodes. If you want to find friends of friends or related products, it can do so efficiently, even across multiple steps. Plus, these databases don't need a fixed schema. You can add new types of nodes or relationships without changing the whole structure, which is great for evolving data models. From a backend perspective, this means building features like recommendation systems or network analysis becomes simpler. For example, a backend can quickly find related products by following the connections between users and items they purchased. Or it can analyze network traffic by modeling devices and their data flows. In essence, graph databases representing complex network data by storing entities as nodes and their connections as relationships, both enriched with properties. This design allows for fast, natural queries on interconnected data, making them ideal for applications that relying on understanding relationships and networks.